Hi everyone, the topic of this video will be coordinate geometry. So to start with, I would like to review some mathematical concepts that is about coordinate geometry, which is to derive the equation of straight line as well as to solve linear equations. And afterwards, we'll go through some problem sets in economics. So let's start with the idea of slope. So how can we calculate the slope? Suppose we have 2 points on the straight line here, 4, 1 and 0, 3. So how can we calculate the slope between these 2 points or the slope of the straight line passing through these 2 points? So it can be calculated as follows. 3 minus 1 divided by 0 minus 4. The change in y coordinate divided by the change in the x coordinate. Okay, so this is what I mean by delta y divided by delta x, or y2 minus y1 divided by x2 over x1. So you are able to calculate the slope here is -1 over 2. So this is the idea of slope. So as you can see here in the diagram on top, y is plotted against x, and the slope coefficient will be expressed by delta y divided by delta x. So in economics, and in particular the demand-supply diagram, we plot price on the vertical axis and quantity on the horizontal axis. So this is why the slope coefficient in the diagram below would be represented by delta P divided by delta Q. At this time, I would like to recall also how we would like to calculate the elasticity using the slope coefficient. We know that the definition of elasticity is percentage change in quantity divided by percentage change in price. And if you decompose this thing a bit, it would simply be delta Q over delta P times P over Q. Because we know that the slope coefficient is delta P divided by delta Q. So this explains why when we are talking about delta Q over delta P, it would simply become 1 over the slope of the demand or supply curve. So I hope this explains why we put 1 over slope as part of the calculation in elasticity. All right, so the next thing I would like to go through would be about equations of straight lines. So if we have 2 points on the coordinate plane, then we are able to draw a straight line that passes through these 2 points, and this would be a unique straight line. Okay, suppose you have 2 points here. I call it 1, 2, and 3, 4. How can you derive the equation of straight line passing through these 2 points? We will express the equation of straight line using a 2-point form. That is, y minus 2 divided by x minus 1 equals to the slope between these 2 points. So this is how we can express the equation of straight line using a 2-point form. So we can further rearrange this expression. So this is how we can derive the equation of straight line when 2 points are given. Alternatively, if we have 1 point on the coordinate plane and also the slope of the straight line, then we are also able to derive the equation of straight line. Suppose now we have 1 point on the coordinate plane, 1, 2, and also the slope equals to 2, for example. So how can we write the equation of straight line? It would be y equals to the y coordinate of the given point over x minus the x coordinate of the given point equals to the slope of the straight line. Then you are able to derive that after some simplification. So this is how I can derive the equation of straight line here. As you can see here, I express y in terms of x, and this is said to be the slope-intercept form of the equation of straight line. We're expressing the equation in the form of y equals to mx plus c. So this form will be quite convenient for us to solve some of the question because we can directly observe the slope coefficient as well as the y-intercept of the equation of straight line from this form. Okay, so yeah, and the next thing would be about the solving simultaneous equations in two unknowns. So I would like to go through three methods with you: method of substitution, method of elimination, and the graphical method. So if we have the system of simultaneous equation of this one, then using the method of substitution, we would like to rearrange one of the equations using a particular variable as a subject. So suppose now I consider the second equation using y as a subject first. And then after that, we can plug in this expression into the first equation. After this substitution, you should be able to see that there's only one unknown x in this equation left, and we are able to solve the value, which is 2. Ultimately, we just put x equals to 2 back into one of the equations, then we are able to solve the value of y, which is -2. This is the method of substitution. And how about the next one? Method of elimination. What we are trying to do is to eliminate one of the variable in the equations first, and then to solve the other variable. Let's say, again, the same system of simultaneous equation here. Suppose I'm trying to eliminate the variable x, and we just subtract equation 1 by equation 2. As you can see here, from this operation, 3x is subtracted by 3x, meaning that the variable x will be eliminated from this equation. And thus, there's only one variable left in this equation, y. This also explains why we can find out the value of y, which is -2. Finally, we just put y equals to -2 back into one of the equations here, then we are able to solve the value of x as well. All right, and finally, method 3 is to use the graphical method. What we need to do is to put the two equations of straight line back into GeoGebra, or to plot the graph on your own, and then you are able to solve the intersection point between the two straight lines. Not surprisingly, we are able to find out x equals to 2 and y equals to -2, the same solution for these three methods. So the final thing I would like to review is about the midpoint formula. Suppose M is the midpoint of AB, then we can calculate the midpoint as follows. So let me go through a simple example to illustrate what it exactly means. So we have ABCD is a straight line on a rectangular coordinate plane, where we have the coordinates of A and C to be -6, 5, and 2, -1 respectively. Better understand their position, let me draw a graph here. Suppose this point A, and we also have point C here. It is further given that AB equals to BC equals to CD. So part A requires us to find the coordinates of point B. From description here, we know that B is actually the midpoint of AC. So how can you find the midpoint of AC? You can use the midpoint formula. As you can see, it is kind of taking the average between the two coordinates of A and C. So for the x-coordinate of point B, it would be -6 plus 2 divided by 2. Whereas for the y-coordinate of point B, it would be 5 plus -1 divided by 2. And this is how we can get the coordinates of B, -2, 2. All right, finally, for part B, we need to find the coordinates of D. And from the description here, we actually know that point C is the midpoint of BD. So how can we back out the coordinates of D? If we let MN to be the coordinates of point D, then we'll have -2 plus M divided by 2 equals to the x-coordinate of point C. And also, 2 plus N divided by 2 equals to the y-coordinate of point C. So solving that out, we are able to find out the coordinates of D, 6, -4. So this is how we can make use of the midpoint formula. And that's all for what I'd like to review. Let's move on to the application problem sets. The first one will be calculating the elasticity of demand using a slope coefficient. So for this question, we have the demand function given directly here. And for question 32, we are required to find the income elasticity of demand for product A. So how can we do that? Recall that income elasticity can be calculated as follows. Delta QA over delta I times I over QA. For the first fraction, delta QA over delta I, it is something related to the slope coefficient. Recall that for equation of straight line, it can be expressed in y equals to mx plus c, where m is the slope coefficient calculated as delta y over delta x. This time, the left-hand side variable is not y. We have QA instead. So the slope coefficient will be delta QA divided by the right-hand side variable in consideration, which is income in question 32. So divided by delta I. So this is why the coefficient in front of the variable y is represented by delta QA over delta I. Okay, this explains why we have delta QA over delta I equals to 1.3. And be aware, it is the slope itself instead of 1 over the slope. How about the second fraction, I over QA? We have QA already directly given in the question, which is equals to 210. How about for I? Although it is not directly given, you can actually plug in all the given information here back into the demand function, then you are able to solve the value of I. This is what I'm exactly doing in this step. As you can see, I have the value of I at the equilibrium equals to 110. So we have all the information in the income elasticity of demand. The I is 110 and the QA is 210. So you can just plug in everything back into this formula, then you are able to calculate the income elasticity of demand, 0.68. How about for question 33? We are required to find the cross price elasticity of demand for product A with respect to the price of product B. So this time we are considering the coefficient in front of PB, the price of product B, and it's represented by delta QA divided by delta PB on the same token. This will help us to calculate the first fraction in the cross price elasticity of demand, delta QA over delta PB. How about the second fraction, PB over QA? Nothing to worry about that because both are directly given. PB is 42 and QA is 210. So we have all the information in the cross price elasticity of demand, delta QA over delta PB times PB over QA. So we can calculate that to be a value 0.44. All right, so hope that's fine for you, and we'll move on to the next problem. So we have the market demand curve and the market supply curve. This question requires us to find the equilibrium quantity and equilibrium price. So this is actually simple. We just need to solve the system of simultaneous equations using the demand and supply curve. So to simplify our calculation, I would like to use the graphical method to solve this part. And let me shift my screen to GeoGebra and to solve it together with you. Okay, so what you need to do is to type the equation of demand and equation of supply. So usually we plot price on the y-axis and quantity on the x-axis. So this is why I would like to use y to substitute P and x to substitute Q. So this is the equation of demand curve, and we also have the equation of the supply curve. Okay, so here the intersection point between demand and supply would be the equilibrium point. So we can just click the intersect function under tools to find the intersection point between the two lines. Finally, we have the equilibrium quantity is 5.56 because the x-coordinate is represented in quantity. And we have the equilibrium price is 33.33 because the y-coordinate is representing the price. So this is how we can quickly solve this problem. And we have the next one. We have the price quantity pairs given here. And also, we know that the demand curve is linear. To maximize revenue, what will be the price of pizza and also the quantity of pizza sold? So because we have two price quantity pairs, we can actually derive the equation of straight line passing these 2 points. And after that, we can find the midpoint of the demand curve, which is also the revenue maximizing point. And this would solve the problem. So how can I do that? I would like to introduce a functionality in GeoGebra to help us quickly derive the equation of straight line passing through these 2 points. All right, so how can I derive the equation passing through these 2 price quantity pairs? So let's type the 2 points in GeoGebra first. The first pair, highlighted in yellow, we have the quantity 1,391 and the price is at 60. So this is the first point. And for the second point, the green one, we have the quantity 907 and the price is 73. So we also have the second point here. What's the next step? We again make use of the functionality in GeoGebra. Click Tools first. Scroll down to find something called Line. What you need to do is just to click the 2 points, and GeoGebra will help you derive the equation passing through these 2 points. As you can see, we have the equation of straight line in the slope-intercept form given here. Okay, so final step is to find the midpoint of this demand curve. Because the x-intercept of the demand curve and the y-intercept of the demand curve are given as follows: 3,600 and something for the x-coordinate and 97 point something for the y-coordinate. So how can you find the midpoint of the demand curve? It is simply the midpoint of CD. So to calculate the profit maximizing quantity first, it would be 3,624 point something plus 0, the x-coordinate of D, divided by 2. And on the same token, for the profit maximizing price, it will be 0 plus 97 point something divided by 2. And this is what I exactly put down in the slide here. We can find out the revenue maximizing quantity, 1,812.42, and the revenue maximizing price, 48.68. So this is how we can make use of the functionality in GeoGebra using the line function and then to find the midpoint of the demand curve quickly. Right? This is the final problem in this video. So as you can see, actually, it involves the idea of taxation. While some of you might have not yet learned the chapter of taxes and subsidies in Econ 1210 yet, it is chapter 6. I believe you are still able to understand this question because I have simplified the analysis such that you can still understand what I am trying to discuss with your knowledge in comparative statistics of market equilibrium. So just try to follow what I'm explaining here to see if you can understand how to solve this problem and to make use of the mathematical knowledge in coordinate geometry in economics. Okay, so for this question, we do not have the demand and supply equations. However, we have the equilibrium price and quantity, and also the slope of demand and slope of supply respectively. So with 1 point and also the slope of the straight line, then we are able to derive the demand and supply equations on our own. Okay, so let's do that first. The first method is to express the equation using the point slope form, what I've just demonstrated during the recall part. For the equation of supply, it will be y minus the equilibrium price divided by x minus the equilibrium quantity equals to the right-hand side, the slope of supply. After some simplification, you are able to derive the equation of supply to be this expression, expressed in the slope-intercept form. On the same token, you can derive the equation of demand as follows. Y equals to the equilibrium price divided by x minus the equilibrium quantity equals to the slope of the demand curve. And we'll have this expression as the demand function. Okay, so this is the first method using the point slope form. Alternatively, you can use the second method I've introduced here. Just directly let the supply and demand using the slope intercept form, y equals to mx plus c. Because we have the slope, what is unknown is the y-intercept of the supply and demand curves. So this is why I let the supply equation to be y equals to 1.4x plus a, where a is the y-intercept of the supply curve. And for demand, I let it to be y equals to negative 4.4x plus b, where b is the y-coordinate, y-intercept of the demand curve. After that, we just need to plug in the equilibrium quantity 57 and equilibrium price 576 back into the supply and demand functions respectively, which is this step. And we are able to solve the y-intercepts of supply and demand respectively. Again, we have the same supply and demand functions. So after deriving the supply and demand functions, it will be useful for our further analysis. So I would like to take this opportunity to demonstrate the calculation in GeoGebra. Okay, so let's start by plugging in the equation of supply and demand first. All right, so this is the demand and supply functions. What's the next step? So because there's a $21 of per unit tax imposed on sellers, from sellers' perspective, their cost of production actually increased by $21 per bottle of alcohol. So this is why we would like to shift the supply curve upwards by the amount of per unit tax $21. So it is simply to add the y-intercept by 21. So the red upward sloping curve will be the original supply, whereas the purple upward sloping curve will be the new supply after taxation. So how can we find out the price paid by buyers and price received by sellers? So the intersection between the demand curve and the new supply will give out the price paid by buyers. As you can see, originally the equilibrium price is at $576. After the decrease in supply due to taxation, the new equilibrium price actually increased to $591.93. It should make sense that the price paid by buyers would increase after an imposition of a per unit tax. How about from the seller's perspective? Because there is a per unit tax of $21, it does not make sense if the price received by seller is higher than the original level, right? We should expect the price received by sellers to be lower than 576 because the sellers is receiving 591.93, and this price actually includes the tax required by the government. So the price received by sellers is actually 591 point something minus the per unit tax of $21. So this explains why the price received by sellers is 591.93 minus 21, which is 570.93. And this makes sense now. The price received by sellers after taxation is lower than the original equilibrium price of 576. So hope you can still follow me in case you have not learned about the idea of taxes and subsidies in Econ 1210 yet. So that's all for what I would like to cover in this video. Thank you very much for your listening.